Hello everyone, I'm here on behalf of SumUp. We're a fintech company. We claim to be a leader, but we're also aware that it's a very high competitive market. And for us, it's important to start with the highlights, the challenge that we are building, right? So for us, 1 billion transactions last year, 2K payments per minute on average, but also all the merchants, all the markets, they're also part of a big ecosystem. For us, the challenge here is that we are also building the get paid stream, which is accepting money, accepting different kinds of payments, but also how we manage the money, how we also expand and run the business. So this is part of a big picture. I'm personally part of the payment tribe. It's a software team. We're also mixing with engineers from Berlin and all other locations. As part of the payment processing, also as Peter mentioned, it's the foundation that needs to build the other sides of some of the business. So for us, it's important to build on a very strong foundation, which means CockroachDB is obviously part of that solution, but it also means that we have a very rich tech radar. It's full of different technologies. We're not the first company, obviously, having a tech radar, but it's up to 150 and even more tools. For us, the highlights are obviously Go, CockroachDB, AWS RDS, which is going to be mentioned a lot, Kafka, AWS ETS, and more. And the big picture is where we started. So as many others, CockroachDB is on the radar for quite some time. In 2020, we started researching CockroachDB. Back then, I was a staff engineer together with my colleague Daniel, who is also in the crowd. And for us, it was very interesting to find a database solution that can build a strong foundation, keep our principles solved, which means I'm going to check in the next slides what are key principles for us. But for us, we started with AWS RDS, which means that we started in 2022 with AWS RDS, Elixir, a bit of Golang here and there. For us, the tech was quite proven over time, which means that it was running for quite a few years. But as I mentioned in the previous slides, it was the traffic was scaling hard. We were reaching new markets, and we were up to a new challenge. We wanted to reach bigger merchants, and this means that for us, using the Debizium, Kafka, having a CDC ingestion with a long-term storage, Kafka Connect, Kafka again, it means that everything needs to be robust across the whole way. This means that the reporting, the analytics, back office, and more need to be highly available, resilient, and consistent. So we started to identify a few problems at this scale. So obviously, vertical scaling. It's a single node, primary write node architecture. It's a single point of failure. Sure, we can scale with read replicas and so on, but there's also the Postgres design, row contention, index contention. We are limited in some ways that cannot just be solved by us engineering. We have to think from the foundation. So we need horizontal scalability, multi-node writes, things that we already heard earlier that CockroachDB provides. And for us, this process meant also identifying the availability and maintenance concerns, which is, as we mentioned before, online schema changes. This means that for us, it's important that scale to be able to deploy migration safely and also think about CDC in a way that is less a hassle and more of an enabler for other domains, like change data capture. We don't need to go even there why we need it. At this scale, event-based systems, event-based architecture, it's a necessary condition. Again, single primary road, night architecture, and also when you enable CDC via Debizium, for example, it's another tool that your organization needs to own. It's another tool that the engineers need to know. And again, we're reaching the operational overhead. We're reaching the point where you have to wake up in the morning, like for example, oh, it's 4 a.m., 5 a.m., we need to do a database upgrade. We even forgot what it's like because we've been using CRDB for over a year now, which means we started relying less on third-party tools like Debizium as part of the whole solution. Rather, we had an all-in-one solution that brings us to what we identified that we need, distributed and native CDC, obviously, highly available cluster. And this means that over time we architected for the foreseeable future. PCI DSS, we all know that. We are responsible in the sense that every fintech company needs to be aware that it's processing cardholder data. It's a necessary challenge, necessary security posture that you need to hold. And Raft is also an important part of the picture because you need to scale with rights, you need a consensus-based cluster, right? And also deep observability. As mentioned earlier, observability is not just your application is running or it's not. For us, we are using, of course, the Prometheus stack, Grafana, all that, Walkie, and so on. But it also means when there's an incident, when there's an issue or you have a concern at this scale, you also need the right tools. For us, the Cockroach Labs Cloud observability tools, which means the UIs, the Prometheus metrics, everything, it's part of the whole picture. And being able to really easily query the whole thing really makes our job easier when we need to respond. And the next thing is obviously zero downtime upgrades, as I mentioned earlier. You just click the button, you upgrade. Also, you still do the end-to-end test, you run the smoke testing, everything, of course. But it needs to be something that you're confident in. ASIC, which is going to be mentioned in other slides also, atomicity, consistency, isolation, durability. It's a very important thing, the way that you design application in your application architecture. SQL, well, you can do NoSQL also, but when you migrate a system that's been alive for 12, 13 years, you get used to a few comforts, and SQL is definitely something that we envisioned as part of our new future with CockroachDB. Online backups, no-brainer, obviously. Provisionable via infrastructure as code. Again, when you scale at 1,000 people, organizations, and more, you cannot just do things manually, so obviously we are relying on infrastructure as code through the whole process. Automatic rebalancing on failure, which, as mentioned earlier, means self-healing, being able to handle network partitions, any kind of disk stalls, downtimes, everything that is going to happen. And it is going to happen because we cannot predict everything in the cloud, right? So about ACID. The reason why I have a specific slide, I'm pretty sure that everyone here knows about ACID. The thing is that I want to put extra emphasis on the fact that it's a very important part of the way you design and scale applications across financial systems. So the guarantees that you have as part of ACID, sure you can go with base or another approach where you handle this on the application layer. But it's important when you're migrating the system, you're severely increasing the complexity of that migration if you, for example, switch from ACID to base, which is also going to be mentioned in the other slides. As part of the whole solution, you have to be aware that you're either shifting guarantees from the database layer to the application layer, or you have to look for a database that has very strong ACID properties and also can be multi-region. And we're reaching to the very important piece, which is the rule of the extra 9. As we are all aiming here, we are aiming for the most 9s, 4 9s, 5 9s, hopefully. But it's very important to be aware that the database is probably the most important dependency in most of the fintech companies, the fintech systems. You rely on that storage. So you can design, architect your heart away with application architecture and trying to deliver the most 9s. But if your application is not the most solid foundation and providing the most reliability you can have, like for example 4 9s and more, you are going to have a very difficult life. So making a decision of what database to use is also being aware that you cannot really compensate for that lack of extra 9s. So Postgres, for example, has its quirks, but CockroachDB for us was a real breeze when we had to provide a database solution which is built on top of CockroachDB, and for us it was really easy to achieve those 4 9s. And again, concurrent systems, consistency models. You've probably seen Yepsen. It's also one of the ways we heard about CockroachDB 2020. It's a well-respected group that does tests on all kinds of storages. And the important thing is, as we mentioned earlier, is that network partitions and being available or totally available is a matter of a lot of conditions. but we are again aiming for the best solution that we can have, which is, for example, whether it's strictly serializable or linearizable without transactions. Again, it's a matter of ACID versus base, which properties you can provide, which properties you're looking for. And there is a lot of solutions that we are going to see in the other slides, but it's important to be aware that if you have the choice to choose the best, which we are ideally looking for state serializable, please go for that. Maybe other domains or other use cases would require less of a state consistency model, but if you have that choice, why not go for it? And the candidates that we reviewed, well, obviously we're here at Roach Fest, so we picked CockroachDB, but we've also reviewed other strong candidates like Yugabyte, HeroDB, MongoDB. And this solution involved a lot of testing on our end over the process of a year, and also devising a migration plan together with the Cockroach Labs team, which was really immense process in its difficulty and how many things we had to consider. But also it was quite a breeze because we were again looking for the same key principles, the same criteria. And this meant that obviously PCI DSS compliance is a must-have at our fintech sector. Consistency models that we were looking for, strict serializable, all that is full of different quirks like write queues, phantom reads, all that when the network conditions are unreliable or you're just deploying in the cloud. That's the new normal. And we were also looking for online schema changes, which means, for example, we were also actively evaluating Yugabyte, HeroDB, MongoDB, and all those different things that the small differences that make a lot of effort easy or they make it impossible sometimes. These are the things that were really important for us to get right from the first time, which means native CDC, multi-region rights. And HeroDB and MongoDB actors, for example, the eventual consistency, as I mentioned earlier, with a lot of tuning, you can get it almost right, but you still would need database transactions. The way that we designed our application architecture at the payment processing domain, it meant a lot of rewriting, a lot of re-architecture. Something that we achieved over the course of a year and a half would be 3 years and maybe even more. So for us, CockroachDB was here the logical choice. And again, operational complexity is something that is really a problem at this scale. Whether you have a native CDC, whether you can be future-proof with multi-region global rights. And the migration plan. Long-term storage fed by CockroachDB CDC, data retention over 6 months, so you can provide a safety net in case you need to provide audit trails, in case you need to do compliance factors, required checks. All that is part of the whole solution. And also, as we were using Elixir in this system over a few years, it also meant extending the Elixir client to support client-side retries. There's a great article in the CockroachDB documentation how to implement your own clients, which means handling specific codes. It means how you're going to retry, whether you need to retry, and so on. For us, it was a matter of human effort, but it was clear what we needed to do. And of course, there's also a specific flavor how you do migrations. In the best case scenario, if you can avoid the data migration itself, do that. In our setup, we had a long-term storage, which is a long-term database, and we could provide a dual setup with AWS RDS and CockroachDB for the sake of the migration, which means introducing a migration proxy and routing based on the UID primary keys. Why am I mentioning explicitly the UID primary keys? Again, something that was part of the CockroachDB documentation, and the architecture and deployment guides were really helpful, but we also stumbled upon this when we were prototyping and testing. So as you're aware, UID is V6 versus V4. The difference is whether one is monotonic, whether it's random, whether it's deterministic. Obviously, they are not deterministic. But it's important whether you want to avoid index congestion and whether you want to avoid hotspots. since CockroachDB works with ranges and its distribution layer is designed in such a way, it means that UADB4 is the natural choice here. So we also had to migrate to UADB4 for future storage. This also severely eased the migration effort, because for us, this meant that by introducing the migration proxy, based on whether it's a UAD v6 or v4, we could know whether to route to the payments gateway, which is the core component that's accepting payments for us, whether we are routing to the AWS RDS database or the Cockroach database. And as we can see from the diagram, in one scenario we have the Bizum, in the other we are going directly to Kafka. As I'm also following the latest news about CockroachDB, I see that there's now a new native format that's similar to the Bizum format. For us, it was a bit of extra effort that we had to migrate exactly to the same format that we were producing after we were consuming the Bizum CDC events. But either way, it was very straightforward. And we were just introducing another CDC ingestion that is feeding the long-term storage, the Kafka Connect, Kafka, and the other parts of SumUp. And both RDS and Roach were really living for a few months together until we completely were confident in the CockroachDB solution, and we decided to gradually shift work to 100% with feature toggles, with traffic switches, and so on. Eventually, we reached agreement that by utilizing the outbox table pattern, which is essentially what I mentioned earlier, as you're familiar with the books of Mark Richards, Neil Ford, their fundamentals about system architecture, about software architecture. By utilizing this pattern, we were able to make sure that migration is happening smoothly, also making sure that we are not hindering the other domains of SumUp. We are able to provide the best latency we can have with the synchronous API, while also producing other CDC events, Kafka events, and so on that other types and domains of SumUp can consume. The migration itself also carries a few details. Since we started managing migration with Elixir, this means we are still continuing to manage migration with Elixir. We will use Golang tools like Golang Migrate or others, but either way, for the sake of the migration, this means using the same migration framework, but you can do it in your own flavor of migration frameworks. We were producing an event outbox table. We were partitioning by partition IDs as primary keys. And there are some minor queries that you need to be aware of, whether you're enforcing event identity, whether you're shifting from insert to upsert, the way that you handle the CDC change feed. But this is pretty straightforward. We still managed to handle it quite well. And the next part, as I mentioned earlier, infrastructure as code provisioning. There's a Terraform provider, and we manage from start to end the users, the roles, everything, the clusters, obviously, since we were creating those on Cockroach WAPS Cloud. And now, the final part. So over the course of, as I mentioned, a year and a half, this involved sunsetting a few components. We are still utilizing Elixir, but we are now more in depth with the Golang ecosystem. We are using the CockroachDB Golang ecosystem clients, the tooling there. We have transformed the migration component, which was the migration proxy, to a payments API, which in future would allow us to scale even further, break down the payments gateway if we decide to use even more CockroachDB clusters. The outboxing CDC stream still powers the post-proxying part. We are utilizing less CDC ingestion components now. Previously, what we used to have for the Bizum, for that specific scenario, we take our RDS, now it's completely gone. We are greatly simplifying the whole thing. And of course, last but not least, the wins, and to recap the whole thing, payments proxying is just one part of the whole picture. There's also the identity, the payments reporting, the payments ledger, POS, and more that are utilizing CRDB. For us, we were, in a sense, the first group that started utilizing CRDB, but together with Cockroach WAPS, we identified a few more use cases. We continued striving to make sure that more domains are multi-region and they're able to be truly global, like deploying across one or two regions, US, Europe, synchronizing. These things are something that you need to handle on your application architecture, but with a database that is so solid that provides all those guarantees, the application architecture is much more simple for us. The multi-cloud is a reality. We're almost exclusive in AWS with a few components in GCP. But being able to scale to different regions where, for example, AWS might not be the most straightforward approach, whether we would use GCP is a very important tool to have an option. Multi-region global clusters, as I mentioned. Through the process, no data loss, zero downtime upgrades. First-party Golang App system, as I mentioned. And last but not least, again, a strong emphasis on self-healing and auto-rebalancing. Because during the process, we were very fortunate not to drop a single transaction, not to have a downtime. We were trying hard to break the whole setup, to be honest, but it was really robust. And last but not least, we also have a London office, so we were here for a while now. So if you're interested to hear more about us, you can scan the QR code and visit us. Thank you.